polygon. I just see what the next one that we talked about is the surface area or the ISO area. A little bit more difficult, but let's go through to use then roads and travel time to calculate the surface area of a specific shopping center, town, or any other entity that you want to create. The difference here from the Thiessen polygon is that you use the distance of the roads. So it don't calculate a straight line, it calculates distance using the roads. Going to switch off my Thiessen polygons, and I'm going to look at my mind map that I've provided, the surface area. So the data that you're going to use here, I think, is only the major towns and the Free State boundary and the Free State roads. You'll find it in that zip area. Okay, your first step after this is you must investigate the data. As I've said earlier, is make sure that the data is projected. And again, how you do that is you look at the, I then normally double click on my layer. It opens the layer properties. I look at the information of that layer, and in this case, it is projected, that UTM zone. Remember the other one that we started with was this Free State major towns, and that one projected. If you see WS84 or Hartebeespoort 94 here, the coordinate reference system, then you know it is not, and if it is in lat long and stuff like that, you know it is not projected. So here in the map, I show you how do you look for the information about the projection. And then the next is to look at your data management. The problem or the issue we have identified earlier is that we need to reproject the data. I've indicated in the previous exercise is you go to your process blocks. I typed in reproject or repro for reproject. There I chose the specific, in this case it will be the Free State major town. Here I chose the UTM 35 South. You will know how to search for that. And then I show OK. You see then there's a new layer in your GIS. Okay, in the next step is to make sure that towns or your points intersect with the road network. Because for the process to work, that point, the town must intersect the line here. It's very important. It will not work if your point that you're going to use does not intersect with the line. So when you're working then with this information to do this processing, is make sure that that line or that point intersect with your line. If it does not, it is wrong. How to do that is, again, you go to your processing toolbox and then you type in snap, and it will indicate the snap geometries to layer. I know it is difficult, but you can watch the videos again, make sure that you know what to do. So you snap geometries. Again, here is the process. The input layer will be then the Free State town, the one that you have projected. The reference layer will be then the Free State roads, because that point must intersect the Free State roads. And I give it a 200 meters tolerance so that it can search for any road nearer than 200 meters from that point. All that you can save it then as a new point. Say my Free State major town snapped. No, it is now correct. You see now, new layer, that was the old one, and now the new one is connected or intersect with the road network. Here you see it's a snap major towns. That green. Important to do that is to ensure that town or the points intersect with the roads. This is the problem, and this is the correct one. I'm going to show you just now how to do it as well. So let's start with that. I'm going back to my QGIS. Remember, I projected that one, so this is the projected one. So I'm not going to show you how to do projection again. So this is the projected one. I think the example that I use is here in Bloemfontein. You see here that point don't intersect with streets, so the process will not work. So what I first do is I type in snap here, and then you see that snap geometries to layer. What it means, it will move or create a new point that connect to the nearest line. So I say snap geometry. I'm going to use major towns. It must connect to my Free State roads. I'm going to give it a 200-meter buffer or tolerance. And then I save to my geodatabase. In my database, I'm going to call it snap major towns. Again, it's a new one, a new layer of major towns. So if I run it, you see there's the old one. In my case, it's snapped to this intersection. So if I switch off the major towns, we're going to use the snap major towns, and we're going to use that. Remember, the roads I've got that from Koch. It is prepared as a network, so all the lines connected to another line, so that the computer or the process know how to follow and use distance or then travel as an indicator. So I'm just going to zoom out to see the whole Free State again. So my data that I'm going to use is my major towns and the street network of the Free State. You can see it is all streets. So what the program is going to do is going to create shortest route between the items or features that we're going to use. Okay, I just want to go back to my mind map. We are finished with the data management. So what we're going to do is we're going to open the analysis part. Again, to start with is that you must install a plugin for this. And the plugin name is QNeed3. So you install that first, you go back to your QGIS, open plugins here, manage and install plugins. Wait a little bit. QNeed3. You click on it. Toby, I see you say that you don't see the buffer shapefile. I think there's only 3. There will be the towns, major town, and the other towns and the streets. There's not a buffer shapefile, if I understand you correctly. So you click on QNeed3, and then in my case it is already installed, so you can then install it in your QGIS. So QNeed 3, install it. Then you will see it is here in your processing toolbox. You see there is the QGIS QNeed 3. So after you have installed that, you can go to the analysis. Okay, so it goes to the one that you're going to use. We're going to use here is ISO area as polygon. So if you open your QNeed here, going to use the ISO areas, and the process that you're going to use is this one, this ISO area as polygons. ISO area is the same as surface area. I think surface area is the one that you use in S3's programs, ArcMap or ArcGIS. So for QGIS, you use this ISO area as polygons. You double click on that, and the first thing that they will ask you is vector layer, the one that we're going to use, FS Streets. It is going to start from our Free State. I just want to check which one is the project. I think it's Major Towns. Projected, and then the snapped one. Let's use the ID. The size of the area for Free State, I've see the works best if you put in 250 meters. The contours, I think in my example, I don't remember in the example, but 15,000 meters is the best contour interval. I will show you after this. So this is 15,000 meters or 15 kilometers. To make the process faster, I normally say 100 meters. Cell size of the interpolation raster is going to use the shortest path and stuff like that. So you can leave. I'm only going to save this one, output interpolation. Save that. Okay, not that one. The output polygon. Save that to our Geo package, and let's call it surface area. Okay, so that's the only thing important here is while it is running is that you use vector data for the towns and for the roads or streets, and important is that your points or your towns must be snapped or intersect with your road network. That is the important stuff, and then you can run this ISO area polygons for your surface area or your area of your towns in the Free State. For your assignment after this, you must do all three. You must provide me with the PDF of all three outcomes. Now let's wait for it to compute. Yeah, it was a little bit fast this morning. I see how calculating that polygons that I'm going to show just now. I think it's almost finished. Okay, there's the surface area. Okay. So I just want to, you see there's all the lines of our surface area. I'm just going to look at the symbology. What I then normally do is I use this categorized, I use this cost level, and the random colors, you can try which color ramp you want to use. I then normally use green or blue. You see the lighter green is when it's nearer to our major town. I then normally just say, okay, invert the colors so that the darker colors are nearer. The first thing that I also normally do is to make it a transparent or a see-through of 80%. So there's our zoom out a little bit. Going to switch off streets. Our switch that off. Going to put it our surface area. Just get my zoom correctly. Maybe switch on our OpenStreet again. Yeah, then you can play around by to cut it out that you don't see that part. Yeah, that is our surface area or ISO area. You can save it in your project and then you can open your, what if I were you, I'm going to open the same one here. So you see it already changed that. I'm going to go just back to so that I can just label it again. ID, and then normally just add a buffer and a mask. Maybe I can make my text a little bit bigger. So there's my town names. Go back to my layout. Click on my layout. Let it just update using this update map preview. But remember, see our legend is not correct. So I click on our legend. I'm going to add a legend layer. Remember the service area. And then I'm just going to change our title. Okay, now I export it. There's my service area or catchment area or travel time map of the major towns in the Free State. Okay, again, you can click there, and there's the two that created the Thiessen polygon surface area. If I go back to my map, so I created now this ISO area polygon exercise. Come on. Just to work a little bit. Remember to install that plugin. If I go back to our agenda, this is our service area or catchment area or travel time. The last one that we're going to use is still a function or a process how you can calculate the surface area or a catchment area or towns that will visit our major town based on distance. We call it nearest to the or distance to the nearest hub, and the end result hopefully will look something like this, where you have then Bloemfontein and people from Boshoff, Brandfort, Jacobsdal, etc. will visit Bloemfontein and not the Bancho or Botshabelo. People from Smithfield will visit the Bancho, depends on what they want to buy or sell there, but it's only to do with distance. They go to the Bancho. People from Winburg will go to Welkom. Of course, it is the distance are smaller. They will not go to Paulroo, to Bancho or Bloemfontein. Depends on what they want to buy or the interaction with the town. Steynsrus people will go to, I think, Kroonstad and not to Paulroo. People from Kestel will go to Paulroo and Harrismith. The same will Heilbron will go to Sasolburg. So the surface area of Welkom, you can say, is this area here. The surface area of Bloemfontein, you can say, is this area here. Or Harrismith is this area here. To do that, the function that we're going to use is, you can find it in backward. It will be this one here, distance to mine. Okay, the data that you're going to use is only the Free State major towns and Free State towns. We are not going to use roads here. So here's the analysis part. I just want to go back to my QGIS, switch all the stuff that I'm not going to use. I'm going to use this major town. Or remember, I already projected it. The other one that I'm going to use is this Free State towns. You see the pink dots here. I'm just going to investigate the properties of towns to see if it is projected. Information, Yes, it is projected, so I'm going to use it as is. Okay, I'm going back to my mind map. The first thing in your processing toolbox, one we're going to use is hub. I search for hub. Distance to nearest hub will come up. So in my processing toolbox, I type in hub, and you see there is the one that we're going to use. Distance to nearest hub. Double click on it. Okay, this course, it is the normal towns because we are looking from small towns. They will go to what? Bigger towns. So the course is Free State towns. The destination will be then the major towns. We use the ID and we use kilometers because it is relative far away. And then here we go to save it to a geo package. We're going to use our course section 3 and let's call it distance to hub. Okay, then you run it. It's an easier, so previous one, there you see is the lines it created. So again, a bit of symbology. I'm going to leave it as orange. I'm just going to make the line stroke a little bit thicker. 0.6. You see there's my distance to hub, or my service area, catchment area, and so forth. Again, just for interest sake, if this is the, you can now add your background. Again, go to your layout manager, open the Thesan one or the first one. You see there's it already. So I'm just going to change my title. I'm just going to change my legend because this one is not necessary. The one that I'm going to add, distance to hub. My legend, all the other stuff stays the same. My title and this one stays the same. So again, I export this. Save it. And then send it to Dr. Boyson. You can upload it in in Blackboard, or you can email it to me. So there's my distance to hub. I just want to check for interest sake if I switch on the Thesan polygons. It is because it use distance, it will almost be the same. You see, there's no point that Will is coming to Welkom, use the same information and not going to Kroonstad. So this is two ways how you can then represent a surface area, a catchment area of a, let's say, a secondary town to a major town in the Free State or in a specific state area. The other one that I've done, but I'm not going to show it here, is to include population of, for example, Bloemfontein and the population of Smithfield and the population of Tabanshu, all the economic activities in Bloemfontein and the economic activities in Tabanshu. I think we know that the economic activities will be bigger or more in Bloemfontein. So if I use that formula, for example, then I think the people from Smithfield will go to Bloemfontein and not to Belo or Tabanshu, because I think here are more malls, more shopping centers, more places where you can buy school clothes, stuff like that. So if you include it in your, we call it gravity model, this surface area or catchment area will change. For example, that Smithfield and Rooiwel will go to Bloemfontein. they must buy their groceries, the children's school clothes, maybe take car for a service, they will go to Bloemfontein and head to Tabanshu. So the catchment area will change depending on what attributes do you add. In this example, we only use distance as an attribute or indicator. That is why say people from Smithfield will go to Tabanshu or Botshabelo, not to Bloemfontein. If you include other indicators like economic factors, maybe then it will look different. So what you must then send to me, I just want to see it is, what you then must send to me is this 3 PDFs. Your distance to hub, surface area, which is this one. You must send me the Thiessen polygon. You see us again, the distance the people will go if you look at the connection. The Tabanshu, the people will go to Bloemfontein, they're staying here, depend only on distance and going here. This one, what makes this one a little bit better, it is used the roads as distance. And for example, if there were a mountain range or something there, the road will be go in between them, and you will see the impact on these circles or polygons. So I want three PDFs from you: distance to hub, the surface area, and Thiessen polygon. Here's the practical Thiessen polygons, surface area or the ISO area, a distance to the nearest hub. And remember, I did not ask it now, but in the exams later on, maybe I will ask, you must interpret, for example, this map. Do the practicals, but add the narrative of how do you interpret a map like this? How will you use it in your research or in your work as a urban and regional planner? How will you use a map like this? We use it then to identify the surface area or the catchment area of a specific town. And if you include economic factors, then you can also calculate the attractiveness of major towns and so forth. And you can use that in your planning or in your SDF or whatever you want to use it for planning. Mostly, the planners use it in their spatial development frame planning tools. The catchment area of your towns or you can use the same methodology for shopping centers and other points that you want to calculate the catchment area. Okay, what I will do is, it is my story for today. What I will do, I will just make a recording of this first part that was not recorded, and I will also add that to the Blackboard. You can download it from there. Again, like I said, I know there will be questions because, it is today is a little bit difficult than the previous sessions. Previous sessions, we only captured data and overlaid and so forth. Today, we did a little bit more practical analysis of towns in the Free State, for example. So, use the WhatsApp group to ask questions, and I will answer it there. Or then, like I've always said, if you want a session a week before, you must hand in your assignment. It is your responsibility to organize it with me, and then we can go through some of the stuff again if it is necessary. So it will be your responsibility to organize a session just before your assignments are due. Okay, that is my story. Like I said, please make contact through the WhatsApp or organize another meeting just before the assignments are due. But if there's any questions, but this is my story. for today. Yeah. Yeah, pleasure. But good luck with the other work. And like I said, please make contact through the WhatsApp group, and organize another meeting through maybe Teams, or we can do it through